Hello guys, I'm Yasir Ali. To continue our discussion about coil tubing fishing tools, here in this tutorial we'll discuss city hydraulic jar. Talking about the introduction to coil tubing jar. Coil tubing jar is a tool that delivers a sudden upward or downward impact force to the tool string below the jar. Simply, coil tubing jar is a tool which is used to provide a sudden jerk or sudden force to the tool string which is installed below the jar. Here we have an example BHA which was run during a fishing operation, which is composed of external dimple connector, back pressure valve, hydraulic jar, hydraulic disconnect, centralizer, dual circulation sub crossover and hydraulic release GS sphere. So here we can see that here we have hydraulic jar. So this hydraulic jar is installed in this particular BHA to provide the sudden impact or jerk to the tools which are installed below. Okay, so this was the point, that it provides upward or downward force to the tool string which is installed below the jar. So below the jar we have this tool string, these are the tools. So when we will activate this particular tool known as hydraulic jar, it will provide an impact to the BHA installed below. Jars are run in most fishing tool strings to provide additional force to free the fish if required. For example, if we don't run a jar in a BHA and we can apply, let's say, 20,000 pounds force, and if we run the jar, we will be able to provide extra force than 20,000, maybe like 30-40,000 pounds extra within the same equipment, same coil tubing, same BHA. If we just install this particular tool known as hydraulic jar, so we will be able to provide the extra force to release the fish. We will understand in our upcoming slides. Talking about the types of jar depending upon the impact direction, we have two types of jar, that is single acting jar and the dual acting jar. Single acting, as the name indicates, provides jerk or impact force only in one direction, either upward direction or downward direction. And the other one is dual acting, that is it provide impact force in both directions. Single tool, single jar will provide force in both directions, upward and downward. Of course, the activation mechanism will be different. If we want to apply force in upward direction, the activation mechanism will be different. If we want to apply downward impact, the activation mechanism will be different, but the same tool will provide impact in both direction, that is upward direction and downward direction. On the other hand, the first type which we discussed, single acting, at one time it will provide only one direction, that is upward or downward. Talking about the applications, that where do we use coil tubing jar, we use most of the time coil tubing jar in milling operations, fishing operations and coil tubing drilling operations. Talking about the types of jar depending upon the working mechanism. Depending on the working mechanism, we have two types, that is hydraulic jar and mechanical jar. And in this particular tutorial, as our topic was coil tubing hydraulic jar, we will understand hydraulic jar in much more detail. So let's go to hydraulic jar. So talking about the working mechanism of hydraulic jar, to understand the working mechanism of hydraulic jar, first we need to understand the structure of hydraulic jar, that what are the main components of a hydraulic jar. So to understand the working mechanism, we need to understand the two main components of hydraulic jar, that is the first part is movable mandrel or piston. So here we have the picture of hydraulic jar which is showing the internal structure. So this is the movable piston or mandrel. Okay, then we have inner bore or cylinder with two sizes. So here we have the inner bore. Okay, here is the inner bore, and the key feature of this inner bore is to have two sizes. Here it have the smaller size, and then when we reach here, its size is increased, and inside the bore we have the hydraulic oil. I'm just repeating again that the main parts which we need to understand the working mechanism. The first one is the movable piston or we can say mandrel. Then we have this inner bore, and the key feature of this inner bore is that it have two sizes. At the start it have the narrow sizes, and then it increases in its size. The mandrel seal slowly travels to a trip point with a larger bore, at which time the flow of the fluid and corresponding travel of the mandrel are no longer restricted. What it's saying, that when we will pull this mandrel will move in this restricted place where the oil movement is restricted, that is, it have the seals. This portion is sealed with this particular portion, and then when it is moving, a point comes, or we can say that a trip point comes when there is no more seal between this part and this part, because here the size has been increased. The design of this piston is as per this bore, the smaller bore. When it will move here, the movement of oil will be restricted, but once this part comes over here, that is at the trip point, or we can say at the point where the ID is changing, the diameter is going to be increased, then this movement will no longer be restricted. It will be free to move, because this hydraulic oil now can pass freely. So that point it is mentioning that the mandrel seal slowly travels to a trip point with the larger bore, at which time the flow of fluid and corresponding travel of the mandrel are no longer restricted. During this process, energy is stored in the form of compressed fluid. So when we are pulling this mandrel, the hydraulic oil is being compressed. So all the pulling energy is being stored in the form of compression. This is the first step we need to understand to understand the working mechanism, that will pull the mandrel, the energy will be stored in the form of compression, and when this mandrel reach at this particular point, that where the die is increasing, this movement of oil will no longer be restricted, that oil will be able to move freely. Then what will next happen? The mandrel will then stroke suddenly. At the limit of travel, the hammer strikes the annual hammer face. So at this point, when the movement of oil is free, all the energy stored will result in at once movement of this mandrel, and then this mandrel will hit the anvil or the hammer face. So all the energy which was being stored in the form of compression is now converted into the kinetic energy, because this mandrel will be able to move fastly. So compression energy will be converted into kinetic energy, and then ultimately this kinetic energy will be converted into potential energy in the form of jerk or sudden impact, which is basically the function of hydraulic jar. So during this process, compressed energy gets converted into kinetic energy, and then ultimately potential energy, which provides the sudden jerk. The jar can be recocked by applying minimum set down force to the tool. On the closing stroke, the passage of oil is unrestricted, that it has check valve. So once the jar is activated, that is the mandrel has been moved to the upward direction. If we want to apply the jar again, what we have to do? We have to recock the jar, that is we have to close the jar. So then what we'll do? We'll provide a slack with the coil tubing. So this mandrel will be recocked, and here we have again the hydraulic oil. So it will provide a downward compression, but to avoid this downward compression, they have put a check valve here. Okay, so when this mandrel will move in the downward direction, there will be no restriction, so we will able to recock the jar in an easy way. So this was the working of hydraulic jar. Okay, talking about the impact force a hydraulic jar can provide. The output force of a hydraulic jar is dictated by the force applied before the jar fires. The greater the upward pull or downward push that is applied to the jar, the quicker the jar will fire, and the greater the resultant impact will be. That is, the impact force depend upon the force applied. Okay, higher the force applied, higher will be the impact. Of course, it depends upon the size of the jar. If we are using lesser size jar, that is 111/16, its impact will be much lesser as compared to the bigger jar 218 or 278. And if we consider the same size of jar, then the force which is applied will decide the impact force. Theoretically speaking, it is said that output force of a jar is typically 3 to 4 times applied overpull. What does it mean? It means that if we apply an overpull of 15,000 pounds, it should exert 45 to 60,000 pounds force or jerk at downhole. It is much more than the applied force. So in this way, this particular component known as hydraulic jar helps in removing or releasing the fish downhole. So that was the discussion about hydraulic jar. I'm very much hopeful that you got understanding regarding what we have discussed. So thank you very much. See you in the next tutorial.